Okay, here we go. This is Module 2, and we're working on Lesson 10 today. So, funny things about today. First of all, big, long, scary objective. No, just kidding, don't be scared. This is really just multiplication. It's decimal multi-digit multiplication, and I swear this program finds crazy ways to make something simple sound so complicated. We're going to multiply decimal fractions with tenths by multi-digit whole numbers using place value understanding to record partial products. So yes, that's a mouthful and it's a lot. And I just don't want you to be scared at all. We're just multiplying. We're actually having simpler problems than in Lesson 8. The only difference is that they're going to toss a decimal in there. And so we have to figure out what to do with it. That's all. And I have the old way and the new way. And so we're going to take a quick look at the new way, which is what this is all about. So the new way is having us think about regular multiplication with a 3 times 2 equals 6. And then they're doing this funny, weird thing that when I was growing up, we never did it. We had a real simple way of solving, but I didn't know why. And so this is why we can do it. So if you take a number and say, multiply it by 10, you're doing some math and you change it. But you can undo that same operation by doing the opposite of what you did before. So let's say I take my product here and I multiply it by 10 to get 60. I could undo that very same step by dividing by 10. So you just do and undo. So let's take that and apply it to decimals. You can multiply the 5 times 3 tenths and get your 15 tenths. Why does this happen? Let's take the decimal out of this by multiplying it by 10. So it's really like a 5 times 3 equals 15. And then you just undo it with the divide by 10. So 5 times 3 tenths is 15 tenths. So if that doesn't make sense, let's take a look at what we're talking about when we decompose decimals or just call it by a different name. So if I have 7 and 463 thousandths, then I could take the 7 ones and then group the 463 thousandths together. Or I could call this 74 tenths and 63 thousandths. So you can break these numbers in different ways. I could take this same number and call it 746 hundredths, ending here, with 3 thousandths. So this is an important idea here, that you can decompose numbers in ways that will help you, okay? So then looking at this one, this is more of what we're doing today, taking a number, estimating it so that I kind of know what I'm shooting for when I get my final answer. So they also use the word units in this book a lot. So if I round 43 down and 2 and 4 tenths down, then I would have 40 times 2 and I should get something around 80. So the book likes to say we have 43 units of 2 and 4 tenths. But take the decimal value and rename it. And instead of calling it 2 ones and 4 tenths, call it 24 tenths. Okay, so that's that decomposition of the number, calling it something else, so that it's easy to work with. So if I have my area model just like we did in lessons 6, 7, and 8, take your 43 over here and your decimal value on top, 20 plus 4. You have all your partial products. And then this is where we're going today, the standard algorithm. So this is where we do and undo. If you take that decimal out of the 2.4, rename it as a unit form, 24 tenths. Multiply as though the decimal is not there, just standard algorithm. You have your label, and then put the decimal back. Same numbers, put the decimal back. It was tenths to begin with, up here, the 2.4. It was tenths to begin with, it should be tenths at the end. That's because it's tenths times ones equals tenths. So if I take it out here, times 10, put it back here, divide by 10. Move it out, move it in. Move the decimal out, put the decimal back in. So that's what today is all about. Now, if that was totally confusing, let's just take a quick look at how things used to be in the good old days when things were really simple, like when I was growing up. So this is the way I learned. Nobody ever told me about renaming. They didn't have us think about place value, and so that was probably why I was so confused as a child. But anyway, if you take your 2.4, multiply it by 43, same problem, okay? I would just look at how many digits were to the right of the decimal, or like, okay, I have a decimal and one digit, do all my work without bothering to figure out where the decimal would go, and then I would match, and that's all there is. That is it. Like, I'm kidding. I'm not even kidding. One place here, one place here. That's the whole lesson. That's all of lesson 10. So everything that Eureka Math does, like hooray for them and all the smart mathematicians, and I was not a smart mathematician, but this is what we're doing, okay? How many decimal places do you have up here? Make it match. Why? Oh, because you can change it to unit form and multiply by 10 and divide by 10 and do all that stuff. I'm going to get the same answer either way. So, with that said, math is so fun. Let's get our workbooks out. Problem set. We'll do a little bit and then I'll talk through it. Wake up. Wake up. Focus. Focus. It's like waking up from a dream. Focus. Focus on the hands, not the backside. They look terrible. Okay. So we have to do a couple things in this lesson. And I'm sorry that already took 7 minutes, but we have to do a few things in this lesson. First, we have to estimate the product. That's the answer to a multiplication problem. Then you have to solve using the area model. Yep, we have to draw more rectangles. Then you have to solve using the standard algorithm. Yes, it's already over here, and they wrote it for you. And look how nice, they changed it to unit form so that you wouldn't have to. You just have to remember to express your products at the end in standard form. So we can do this, and it's really easy, I promise. 22 is pretty close to 20. Notice that funny squiggly equals. That means is approximately equal to 20. And 2.4 we can change to 2. So 20 times 2 is approximately 40. So my final answer should be approximately 40. So let's make our model, and I want to start with 22. I'll put this one on the side because I want to have this one on the top where I can separate out or rename my digits. So this is 2 ones and 4 tenths. Let's use unit form. And I eventually want these to match my partial products. And so then we have our 2 times 2 ones equals 4 ones in our unit form. And 2 times 4 tenths is going to be 8 tenths. And then 20 times 2 is 40 ones. And 20 times 4 is 80, but it's tenths. Okay, so 4 ones, 8 tenths is really 48 tenths. Okay, so let's pay attention as we do our standard algorithm. This has been renamed, so we've taken our 2.4 and we don't have the decimal, and I don't need it. If I put it there, that would be redundant. That means saying it 2 times, and we just don't need to say it 2 times. Once is enough, and it's right there. 2 times 4 is 8. 2 times 2 is 4. So look, I got 48. Now, is it 48 tenths? It doesn't matter. I'm not finished yet, okay? So the second partial product, if I have finished with this one, remember the ghost 0 can hold that place, so you can shade it in. And then 2 times 4 is 8, and 2 times 2 is 4. And of course, we get the same numbers because it's the same. We love that. and then add, and then 8 plus 4 is 12, and carry that 1, and then you have your 528. 528 what? Well, it's 528 tenths, because it was tenths times ones, and that makes tenths. So what does this look like? 40 ones. Now remember, if 40 is like that, standard form, but 80 tenths is like that. Remember? Remember that? We did this a few lessons ago. So 40 plus 8 is actually 48 ones and 0 tenths. And that's what we have here. Okay? So because this is tenths. So our final answer, as we take our 52, or let me just say it both ways. 528 tenths has the same value as 52.8, which is our final answer in standard form. Okay? This is that. They are equal. So I hope that's not too confusing. When in doubt, just look up here, and if it was 2.4 times 22, and you do all your math, you just have one place value position, so put 1 in at the end. And it's really that simple. That's all there is to it. So all this craziness in here, we're just, count that place. Okay, put it back. So this is approximately equal to what? That's approximately 3, and this is approximately 30, and so I should end up with approximately about 90. So let's take our decimal value, and we'll create our model. 3 ones, 1/10. And then 33, I'm going to do 30 and 3. It has to be stacked up that way, otherwise your partial products will not align. Okay, so 3 times 3 ones, 9 ones. 3 times 1/10, 3 tenths. 30 times 3 is 90. We're still talking about ones. And then 30 times 1 is 30 tenths. Now again, if I add these up in standard form, okay, so you can see what's happening with all these tenths and the numbers that we're putting together. 9 ones plus 90 ones is 99 in standard form. 30 tenths plus 3 tenths is 33 tenths. But think about this in standard form. That is 3.3. This is the tenths place. Tenths makes me want to lisp. This is the tenths place. 33 tenths has to end here. So this is what it looks like in standard form, which is going to make it line up here when I add those two together for my partial product. So just pay attention. Again, same setup, but no decimal. They took it out, changed it to a word, and that's the same thing as having a decimal in there like that one. But we're going to work with it not being there. 3 times 1 is 3. 3 times 3 is 9. They gave us really easy problems for today because they want to keep it simple. 3 times 1 is 3. 3 times 3 is 9. Bump them over, add them up, 9, 10, 11, 12, and 10. So there we go. But this is really tenths. And so in standard form, we have our equal answer of 102.3. And that's your final. And again, if you want to connect, 9 ones plus 3 tenths would be that 9.3, which would be here. And then the 90 ones and 30 tenths, be super careful because that's 93 ones. Okay, so it should be aligning in the same way that it was before. Then we drop off the area model for the bottom part, which is, it's fine. Like, it's kind of a hassle to have to make the area model. So I'm going to jump right in to our bottom of the page and just kind of show you the finished work and talk you through it. 3.2 is really close to 3. 47 is close to 50. 3 times 5 is 15. Don't forget the 0. They took the 3 and 2 tenths and called it 32 tenths and took the decimal out and put the unit in. Work it out so that you don't have to think about where the decimal is. 7 times 2 is 14, carry the 1. 7 times 3 is 21, plus 2, plus 1 is 22. Looking ahead, don't do that. There we go. Hold that with the ghost 0. 4 times 2 is 8, 4 times 3 is 12, nothing to carry over, that's from before. Add them up. That's 4, then 10, carry it over. 2 plus 2 is 4, plus 1 is 5, and then this is your final answer in unit form, tenths. That in standard form has 1 decimal here. And in the same way, over here, we have approximately 3, approximately 90. 3 times 9 is 27, and a 0, 270. Take the 3 and 2 tenths, take the decimal out, give it unit form. Multiply as though the decimal is not there. Put it back in at the end in unit form. It was 1 place value position here. It's 1 place value position here. Okay. Next page. I'll just talk you through them real quick. Too many books. All right. Don't get distracted now with all those answers. All right, so 6.3 is approximately 6. 44 could round down to 40. 6 times 4 is 24. And then you have this 0, 240. It's 63 tenths. Change it to unit form. Set up your standard multiplication. 4 times 3 is 12. Carry the 1. 6 times 4 is 24. Plus 1 is 25. Ghost 0. Move to the tens place. 4 times 3 is 12. 2 down, 1 up. 4 times 6 is 24, plus 1 is 25. Put your line in. Add 2, 7, 7, 2. It's tenths. This is tenths. Put the decimal in standard form, and that's your answer. Easy peasy. See how easy it is? I know you guys are loving this right now. 14.6 is pretty close to 15. 17 is pretty close to 20. Let's use those. Then I have 15 times 2, which is 30. And then don't forget the 0. Boop, boop. Okay. Now for this one, we have 146 tenths times 17. Standard algorithm. 7 times 6 is 42. Carry the 4. 28 plus 4 is 32. Carry the 3. 7 times 1 is 7. Plus 3 is 10. 1022 should be your first partial product. Hold the 0. Hold this place with a 0. Ghost 0. Then 1 times 146, it's 146. 1 times 6, 6. 1 times 4, 4. 1 times 1, 1. And then add those. 2 comes down. 8, 4. 1 plus 1 is 2. This is really tenths until you put the decimal in. Then it's tenths. What a surprise. Tenths is tenths. Next ones. 8.2 is approximately 8. 34 is pretty close to 30. 8 times 3 is 24. Don't forget the 0. Change this to unit form, or, like we like to say, take the decimal out and put it back in. And let me move that so you can see it. 4 times 2 is 8. 8 times 4 is 32. Hold this with a ghost 0. 3 times 2 is 6. 3 times 8 is 24. Add, add, add. Drop it down. It's tenths, so put in the decimal. 160.4 is pretty close to 150. It's also close to 160, but I don't really know my 16 times tables. I do know some 15s that are in low amounts, so you could use 16 if you wanted to end up with 32, but if you don't know that, which most 5th graders won't, then you can just use 15. What if you rounded it to 20? Would that be okay? Sure, this is just an estimate. Remember, you're just trying to get somewhere close so that when you compare at the end, it's like, yeah, I'm not too far away. I am not too far. Oh, and I just realized that I haven't been comparing our estimated answers, but look how close they are. Hooray! So here we have our tenths. Again, we're just working with tenths today, not making it too hard. 7 times 4 is 28. Carry the 2. Look, a 0, it falls down. 7 times 6 is 42. 2 goes down. 4 goes up. 7 times 1 is 7, and 4 is 11. 1, 1, 2, 2, 8. That's a fun one. Hold it with a ghost. 1 times 4. Oh, look, it's a 1. It's going to be 1604. That's what I guess. 1 times 4 is 4, 1 times 0 is 0, 1 times 6 is 6, 1 times 1 is 1. I was right again. I love that when I'm right. Multiplying with 1 is so fun. 8 plus 0 is 8, 4 plus 2 is 6, 2 plus 0 is 2, 6 plus 1 is 7, and 1 plus 1 is 2. There you go, bam. It's tenths. Put the decimal in, and you move on. Okay, word problems. These are always fun, especially when you have to think and justify. Michelle multiplied 3 and 4 tenths times 52. She incorrectly wrote 1,768 as her product. That's the answer to a multiplication problem. Please remember that. Use words, numbers, and or pictures to explain Michelle's mistake. So first of all, if you think about what she should be getting, it's approximately 3 times 50, really. So 3 times 50 is about 150. So when I look at this, I go, yikes, that is way off. Remember, we were talking about this is 4 digits and this is 3. I automatically should be red flagging this answer as something's wrong here. So take your 3.4, make it 34 tenths, or just do the multiplication. Okay, pretend it's not there. 2 times 4 is 8, 2 times 3 is 6, ghost 0. 5 times 4 is 20, this is the 0 from the 20, carry the 2. 5 times 3 is 15 plus 2 is 17. Bring this down, 8, 6, 7, 1. It's tenths here, so it's tenths here. If it's 34 tenths, so the answer should be in tenths. And so essentially, we're using numbers to show the mistake that this is closer to our estimate than that would be. Okay? She is way off because she doesn't have a decimal here. She's using all ones instead of tenths. And finally, wire is bent to form a square with a perimeter of 16 and 4/10 centimeters. The perimeter. Okay, how much wire would be needed to form 25 such squares? So if we have our, I should have looked at this one before, I haven't thought about it in a year. Ha ha ha. Okay, we have 164 tenths, so rename this. Okay, and multiply it by 25 such squares. And so you have your 5 times 4 is 20, carry the 2, 5 times 6, 30 plus 2, 32, 5 times 1 is 5 plus 3 is 8. First partial product, hold this place with a ghost. 2 times 4 is 8, 2 times 6 is 12, carry the 1, 2 times 1 is 2 plus 1 is 3. Next partial product, add them up, okay? And so we have our 410 centimeters. Now it says express your answer in meters. And again, if I had tenths here, I have tenths here. This is that whole do and undo, or multiply by 10 and then divide by 10 to put it back. When you convert, that's what I have here, you go back to the King Henry died unexpectedly drinking chocolate milk. And I have to get from centimeters to meters. That's a 2-position hop. 2 positions. 2 place value positions means 2 zeros. So since I'm going from small units to large units, that's when you divide. So you take your 410, divide it by 100, shift the decimal 1 2 places to the left, and you end up with 4 1/10 meters. And that's how much wire would be needed. Boop, boop, boop. Okay, so I hope that's all crystal clear. Hope you guys enjoyed lesson 10, and I'll see you real soon. Bye.